Welcome to your severe weather analysis for Port Hedland, Tuesday, November 25, 2025. This morning, sounding from 10 a.m. local time, reveals a complex atmospheric setup with limited thunderstorm potential but notable instability aloft. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at this morning's Skew-T diagram, we are seeing a very dry and stable atmosphere at the surface. The temperature profile in red and dewpoint in green show a significant gap near the ground, with surface temperatures around 28 degrees Celsius and a dew point of 23 degrees. The blue shaded area shows convective inhibition, or CIN, acting as a strong lid holding down any potential convection. There's a notable inversion near the surface marked on the diagram, where temperature actually increases with height, creating additional stability. The mixed layer CAPE is only 307 joules per kilogram, which is quite marginal for thunderstorm development. The lifted condensation level sits at 679 meters above ground, which is relatively low. However, the most unstable parcel does show 1106 joules per kilogram of CAPE, suggesting there's energy available if we can break through that capping inversion. The CIN value of 265 joules per kilogram represents a formidable barrier that would require strong surface heating or mesoscale lift to overcome. Now let's examine what happens as we move into this afternoon. The enhanced Skew-T diagram shows the transformation when we heat the surface parcel to the forecast maximum of 32 degrees Celsius. The pink shaded area represents CAPE, the fuel available for thunderstorms, and you can see how it expands dramatically compared to this morning. The blue shaded CIN area shrinks considerably as surface heating works to erode that capping inversion. The heated surface-based CAPE climbs to nearly 2,000 joules per kilogram, a significant increase from this morning's values. The level of free convection, marked as LFC on the diagram, drops to a more accessible height. However, we still have 61 joules per kilogram of CIN remaining, and the forecast maximum of 32 degrees is slightly below the cap break temperature of 32.4 degrees. This means storms would be conditional, requiring an additional trigger mechanism like sea breeze convergence or orographic lift. If storms do manage to initiate, that 2,000 joules per kilogram of surface-based CAPE would support moderate updraft strength, but the relatively weak wind shear of 8.5 meters per second through 6 kilometers limits organization potential. Looking ahead to tomorrow morning, Wednesday at 10 a.m. local time, the machine learning model forecasts minimal thunderstorm potential. Mixed layer CAPE drops to just 21 joules per kilogram with surface-based CAPE at 789 joules per kilogram. Wind shear remains weak at 5.3 meters per second. The lifting condensed level stays low at 452 meters, but with insufficient CAPE, the atmosphere will be subconvective. Both supercell composite and significant tornado parameters remain at zero, indicating no organized storm threat. Tomorrow afternoon, Wednesday around mid-afternoon local time, conditions improve only marginally. The model shows 55 joules per kilogram of mixed layer CAPE and 722 joules per kilogram of surface-based CAPE. Shear increases slightly to 6 meters per second through 6 kilometers. The LCL rises to 689 meters above ground. The SHIP index, which combines instability and shear for severe hail potential, registers only 0.5, well below the threshold for organized storms. All threat indices remain at zero, confirming subconvective conditions through tomorrow afternoon. The hodograph reveals the wind structure through the lowest 12 kilometers of the atmosphere. Starting from the surface in dark blue, winds are light and easterly. As we climb through the boundary layer shown in cyan and green, winds veer toward the east and southeast, creating modest directional shear. The yellow and lighter colored points represent mid and upper level winds backing toward the east-northeast. The bunker's right mover storm motion vector, marked with the red star, points toward the south-southwest, indicating that if any supercells were to develop, they would track in that direction. The 0 to 6 kilometer bulk shear of 8.5 meters per second is marginally sufficient for storm organization, but below thresholds for supercells. Storm relative helicity in the lowest 1 kilometer is 104 meters squared per second squared, and 167 through 3 kilometers. These modest helicity values, combined with limited CAPE, result in a supercell composite parameter of just 0.24, well below the threshold of 1.0 for supercell potential. The atmospheric refractivity profile, or n-squared profile, shows vertical stability throughout the column. The blue line represents the Brunt-Väisälä frequency, which measures how strongly the atmosphere resists vertical motion. The orange shaded area near the surface, labeled as elevated duct, indicates the strong surface inversion we identified on the Skew-T diagram. This creates a zone where radar signals can propagate horizontally rather than vertically, and more importantly, where rising air parcels face significant resistance. Higher in the atmosphere, Between 1,000 and 4,000 meters shown in yellow, we see regions of superfraction where the atmosphere is less stable. The profile shows high-end values near the surface confirming strong stability, then decreasing values aloft where the atmosphere becomes more conducive to vertical motion if a parcel can penetrate the low-level cap. In summary, Port Hedland faces a capped environment this afternoon with conditional thunderstorm potential. While afternoon heating will build nearly 2,000 joules per kilogram of surface-based cape, the persistent capping inversion and marginally sufficient wind shear limit severe weather potential. Tomorrow shows even weaker instability with subconvective conditions expected. Always consult the Bureau of Meteorology for official warnings and forecasts, as this analysis represents atmospheric ingredients only and does not predict storm initiation. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.